Okay, I want to look at a couple of limit examples, 3 to be exact, and they all involve square roots. And I think sometimes these can be confusing for students, so I'm going to show you the tricks on how to deal with these. Okay, so for this first one, we have the limit as h approaches 0 of the square root of 9 plus h minus 3 all over h. And you notice, first of all, we need to try, if I plug in h equals 0, you should end up with a little bit of a problem, not too bad. You end up with 0 over 0. If you get a 0 over 0 question, that usually means that algebra can help you somehow simplify this thing. And in this case, what you need to do is multiply by what we call the conjugate. And what the conjugate is when I take this square root expression in the numerator, instead of saying minus 3, I'm going to say plus 3. I'm going to multiply the numerator and the denominator by this conjugate. Now at this point, it looks like I've made things more complicated, but actually it's going to help, and I'll show you how. Okay, so we have here, this is equal to h, limit as h approaches 0. Let's do the denominator first. We have h times the square root of 9 plus h plus 3. Should you distribute that h in the denominator? No, just leave it like that, that's fine. What really is helpful is in the numerator. Okay, in the numerator, I'm going to have to FOIL these two really ugly expressions. And so first I have the two first terms multiplied together. So I have the square root of 9 plus h squared. I'm going to write that out. And as soon as I write it out, you can see how that simplifies. Secondly, I have the outside terms. I have 3 times the square root of 9 plus h. Not a nice thing to deal with, but in the middle, the inside, I have minus 3 times the square root of 9 plus h. And so those are going to actually subtract out. And then lastly, I have minus 3 plus 3, which is a minus 9. Okay, so from there, we start to simplify. The limit as h approaches 0. My denominator still, let's just leave it as it is. It's not really causing any problems. It's the numerator. But now we see that these two middle terms cancel out. And my first term just becomes 9 plus h, because the square root of 9 plus h squared is just 9 plus h, minus 9. Okay, so now in the numerator, all of that stuff just simplified to h. And so in the denominator now I have the h times the square root of 9 plus h plus 3. And I can cancel out an h out of everything, which was causing the problem. And so I end up with something I can plug in h equals 0 for. And the numerator have a 1. And the denominator have the square root of 9 plus 0 plus 3. So you end up with 1 over the square root of 9, which is 3, plus 3. You end up with 1/6. There it is. Okay, the same trick that I used in part A will work in part B as well. And the first thing though we need to do again is to make sure if I plug in 0, let's see, I can end up with, in the numerator, end up with the square root of 1 minus the square root of 1. So that's 0. And the denominator have a 0 as well. So I have a 0 over 0 situation again. Again, algebra is going to help me with this. And in the same way, I'm going to multiply by the conjugate. And this conjugate looks a little nastier than the last one, but it still works the same. So I end up with the square root of 1 plus t plus the square root of 1 minus t in the numerator and the denominator. Again, why does this help? Because now when I start distributing these terms, things are going to clean up for me very nicely. So in the denominator, again, let's just leave it alone. You're just making life more complicated on yourself. If you try to distribute that t, there's not really a point in doing that. In the numerator, though, when I FOIL these out, I end up with the square root of 1 plus t quantity squared. The outside terms multiply to give you the square root of 1 plus t times 1 minus t. The inside terms multiply together to get negative square root of 1 minus t times 1 plus t. So those two are going to cancel out, and that's why the conjugate is so helpful, is because the middle stuff that would not be squared cancels out every time. So the last terms here, I have a minus square root of 1 minus t quantity squared. Okay, so the way this simplifies now is in my numerator I end up with 1 plus t minus a 1 minus t. And the denominator have t times the square root of all this stuff. Okay, I still can't plug anything in. You notice anytime you can check, you're going to get 0 over 0. So in the numerator though, notice what happens. I have a 1 minus 1, so those are going to cancel out. And I have a t minus a negative t. I end up with, in the numerator, with the limit as t approaches 0 of 2t, and the denominator t times all this stuff. And so now I can see my t's cancel out. And at this point, I should be able to plug in 0. When I plug in t equals 0, I end up with 2 in the numerator, and the denominator end up with the square root of 1 plus 0 plus the square root of 1 minus 0. Okay, so that's 2 over the square root of 1, which is 1, plus the square root of 1, which is 1. So I end up with 2 over 2, and I just get 1 as my answer. Okay, I hope those make sense. Okay, I'm going to show you part C, and this example has a square root involved, but it's a little bit different. Well, it's not really. I mean, if you plug in 25 in this case, notice in the numerator you're going to have 5 minus 5, that's a 0. And in the denominator you're going to have 25 times 25 minus 25 times 25. And that's 0 as well. So here I'm going to try to use algebra, and I can multiply by the conjugate, which is 5 plus root x in the numerator and in the denominator. Okay, and this will be helpful. So let's see, x approaches 25. In my numerator here, let's see if we can work it a little quicker than we did the others. I have 5 squared, which is 25. I have 5 times root x, but then I have minus 5 times root x as well. Those cancel out, so I end up with minus square root of x squared, which is 25 minus x. In the denominator, okay, out of this first term, let's actually factor out an x first, because then, if you notice, you get the 25 minus x that we're about to cancel out. And then I have 5 plus square root of x. Okay, so at that point, I can cancel this term out, and you can only cancel out a term if it cancels out of everything. Here it does. And so at this point, I'm allowed to plug in 25. So in the numerator, I get 1. In the denominator, let's see, I have 25 there times 5 plus the square root of 25. Okay, so that's what I'm left with. And what is that? That's 1 over 25 times 5 plus 5, which is, 5 plus 5 is 10. So I end up with 1 over 250. There's your answer. Okay, now actually, let me show you one other quick way to do this. This one I didn't actually have to multiply by the conjugate, because what I recognize here is that in the denominator, once I take out the x, I have 25 minus x. That's actually the difference of squares in this sense. You wouldn't normally factor it this way, but because of the numerator, I have a little bit of a tip that this thing can actually factor as 5 minus the square root of x times 5 plus the square root of x. And if you don't believe me on that, check it. If you FOIL this out, you get 25 plus 5 root x minus 5 root x, and then minus x. So you get the same thing that we had up here. Okay, so that, and once you cancel, notice, once I cancel, I have the exact same expression that we had on this side. Okay, so at that point, you end up with the limit as x approaches 25 of 1 in the numerator over x times 5 plus root x. And again, you end up with 1 over 250. So if you see a question similar to this, where you have something kind of like that, just remember that you can factor this denominator as the difference of two squares. But if you have to, just use the conjugate. That's totally fine. Okay, these are 3 examples. I hope they make sense. I hope the process seems simple enough. If you have any questions, please let me know. You can leave them in the comments. You can send me an email. And just thanks for watching.